Hi, General Math. Eli just let me know that the assignments have been backwards on the board, and that's the first I'd heard about it. So this new one today, I'm not until I find out people absolutely can't use the other ones, the first two, I'm gonna let those go. But this is the assignment for today. I'm re-recording it so I can send it out to you forward. I can't tell from this way whether I'm actually on screen or not, so I'm just gonna kind of have to make a guess. So I'm on page 148. We're doing the second half today. So it's going to be, let me get a pen just a second. I call it 148 General Math, page 148b, since we're talking about the second half. And so today we're actually going to be doing 28 through 60 evens. Okay, there's a couple things that we're going to be doing. We're going to work a little bit more with prime numbers because we need those in order to do factor trees. We're also going to be learning about greatest common factor. Okay, let's start with greatest common factor. Wait a second. Greatest common factor. Factors, if you recall, are the bits and pieces that break down to multiply to be that number. So if I were doing 20 and 25, the factors of 20 are 1 times 20. 2 goes in there because it's even. That's 2 times 10. So I just divided 20 by 2 and got 10. 3 doesn't go in because 2 plus 0 is 2. 3 doesn't go into 2. 4 goes in. That's 4 times 5. And notice these are close together now, so there's nothing that I can do in between. 25 greatest common factors. So we have to list the factors first. 1 times 25. 2 doesn't go in because doesn't end in 0, 2, 4, 6, or 8. 3 doesn't go in because they add up to 7. 3 doesn't go into 7. 4 doesn't go in, but 5 goes in, and that's 5 times 5, which meet together in the middle, and I don't have to put it up twice. So 1, 5, and 25 are the factors of 25. So we need to know all the common factors right here. The common factors are 1 and 5, and we need the greatest, so my answer is 5. So the greatest common factor is 5. So you'll list all the factors out, and then you pick the biggest one that is in common with both of those. Okay? All right, the other thing we're going to work on is actually this was the second section. This was from 38 to 44. All right, the section before that is working on factor trees. For this, you have to know what prime numbers are. Now, we worked a little with prime numbers before, so I'm going to go ahead and set them out over here, the lowest ones. So we'll never put a 1 as part of the end of the tree branch on these. So a prime numbers are 2, 3, 5. Remember, they only have nothing else goes into them except 1 in themselves. 5, 7, 11, 13. That should be high enough for our purposes today. Okay? There are many more higher ones. Okay? So today we're going to be talking prime factorization, which always means, this word right here means do a factor tree. Okay, so if we were going to do a factor tree for, say, 75, I need to break it down into all the prime numbers that when you multiply them together, they're going to multiply to be 75. So I need 2 numbers that multiply to be 75. Well, if I think of 75 as 75 cents, and that's 3/4, right? So I know that a quarter is 25 cents, so 3 times 25 would work. You could use 5 times 15. Anyone's will work because we're all going to get the same answer at the end no matter which ones we pick here, as long as you pick ones that actually go in, okay? Well, 3 is prime, so that's the end of that tree branch. But this one right here, 25 is not prime, so I need to split that up because it is 5 times 5. I can't use 25 times 1 because at the end of these branches I can't have a 1. I have to be able to split it up. 5 is prime, so it's these three right here. I write now all of the tree branches have a circle at the end because they're all prime numbers. So I put them in numerical order, so that's going to be 3 times 5 times 5. Which if we use it during exponents, they're using exponents, that's 1, 3, and it's 5 to the second power. We need to put the multiplication signs in between. So this will be your answer, or this. Sometimes they'll ask for it in exponent form, and you would write this. Okay? Shall we do one more? Let's try 100. Okay, we could put lots of things go into 100. So we have to find two numbers that multiply together to be 100. You could do like 25 times 4, or 10 times 10, or 50 times 2, all of those things. We just need to pick one set that multiplies up, any set that multiplies up to that. Let's do 10 times 10. All right, is 10 prime? No, because it's 2 times 5. So I have to split that up into 2 times 5. And this 10 will also split up into 2 times 5. Whoops. 2 times 5. So 2's prime, 5's prime, 2's prime, 5's prime. So each of these are prime numbers and my tree branches have all ended. So now I put them in numerical order. So 2 times 2 times 5 times 5. 2 times 2 times 5 times 5 in numerical smallest to largest. And then exponent-wise, we could do 2 to the second times 5 to the second. So whichever one you come up with, whichever they ask for is fine. If they don't ask, you can choose which way to do it. Okay? I think that's all you have to do. Remember, the words prime factorization mean do a factor tree and write these down here. Now you will notice if you punch in your calculator 2 times 2 times 5 times 5, you get 100. So you can check your answer and make sure you got it right. Make sure you did everything right here. Okay, hopefully this was all on your screen and hopefully you understood everything and it's right side forward, okay? Good luck with this next lesson, okay? I'll get this posted right away and out to you. Have a good day.